Alright, so here's one problem. And of course you can pause the video if you want to try to sketch this out yourself and do it along with me, but I think if you just follow along you'll have plenty of sample problems in the book to try. Circle F is shown, tells me F is the center, and I'm being asked to find the measure of a whole bunch of angles. The best tip I can give you with doing little puzzles like this is to try to fill in all the arc measures first. Let's see, arc UW 92 degrees. Arc XY 40 degrees. Arc XY 40 degrees. Arc TZ 28 degrees. Measure of arc UT 86 degrees. And arc WU and YZ are congruent. Well, we already said WU is 92, so that means YZ is also 92. And there's one missing arc there. So what I'm doing, you don't need to see my calculator, I'm just going to tell you what I'm doing. I am adding up all the arc measures that are currently there, and I'm going to subtract from 360, and I get 22 degrees for this arc. So now I have all of the arc measures all the way around the circle adding up to 360. So now I can start getting my angles. Angle 1, well, that's on the circle. That angle is going to measure half of its arc. Its arc is 40 degrees. Sorry, I moved the paper. 40 degrees. So this angle is going to be half, 20 degrees. Angle 2, vertex is on the circle. Its arc, if we follow the sides out, measure 86 plus 28, 114 degrees, so that would be 57 degrees here. Angle 3, on the circle, so we follow the angle out. It touches at Z and U. Same two arc measures, they add up to 114, half is 57, and hopefully right now you're noticing, oh, the bow tie theorem. Do you see that bow tie? All four corners are on the circle, so these angles had to be congruent. Angle 4 is going to be half of 40, so 20, and there's the other corner of the bow tie over there. Now angle 5, be careful. Where's the vertex? It's not on the circle, it's at the center of the circle. That's a central angle. So that angle is going to be equal to the arc measure, so that's 28 degrees. Angle 6, where's the vertex? It's on the circle. So we check out the arc. It goes from U to W. So half of 92, I think, is 46 degrees. There's angle 7. Now I want to show you something. I bet you everybody watching can figure out what angle 7 measures because of this triangle. But I'm going to show you something, a little bit of foreshadowing for things to come later in this chapter. If I ask myself, where's the vertex of angle 7? Is it at the center of the circle? No, it's not. Is it on the circle, like angle 3's vertex? No, it's not. This one is just in the circle. We have not learned that yet. But check this out. Its arc goes from U to X. So that arc measure is 114 degrees. And then look at the vertical angle to angle 7. We know vertical angles are congruent. Its arc goes from Y to Z, 92 degrees. So angle 7 makes an arc of 114, and the vertical angle makes an arc of 92. 114 and 92, if you can get a shot of this. 114 plus 92, and I'm going to add them up and divide by 2. In other words, I'm taking the average of those two arcs, and I get 103. And I bet if anybody's already finished off that triangle, I bet you that's the answer you had, 103 degrees. So it turned out angle 7, with the vertex in the circle, came out to be the average of its arc and the vertical angle's arc. Something to keep your eyes open for later on in this chapter. I'm going to show you one other kind of problem, and then I'll leave you alone. I'm not even going to do this. I don't even know what the question is on this problem. I just made this up without even asking the question, just to show you and remind you of a couple of strategies. So if I was going to be asked to find some angle measures in here, and the given information is segment FR and segment DY are congruent, I need to remember the older theorems from earlier in the chapter. One of them was congruent chords chop off congruent arcs. Congruent chords create congruent arcs. So when I'm told, or if I can figure out this arc measure, I'll know that arc measure. And sure enough, we're given the measure of arc YD to be 120 degrees. So now I know that this arc is 120 degrees. Arc RD is 40 degrees. So if I look around my circle, so far I've got 120 plus 40 plus 120, that's 280 degrees accounted for. So it must be 80 degrees left over for this arc. And we had another theorem earlier in this chapter. Something about when a radius is perpendicular to a chord. Can you remember that theorem? If a radius is perpendicular to a chord, we said it will always bisect that chord, but it also bisects the arc. So if this is 120 degrees, we actually know that it's 60 and 60 because of that perpendicular radius. Same thing over here, perpendicular radius to a chord. It's going to bisect this arc. So this is 60 degrees and 60 degrees. So this is how you want to try to start these problems. Get any arc measures you can. So now if I want to get this angle, well, it's on the circle, it's half of 40, 20. If I wanted to get this angle, it's on the circle, half of 80 is 40. If I needed to get this angle, I would say, well, the vertex is at the center of the circle, so this angle is going to be equal to that arc of 60, and so forth. Try to get the arcs first and remember your older theorems. Good luck.